Where does the resonant energy in an electric resonance system come from? Well, theoretically, it comes from the power supply that feeds the resonance system. But how do we check that? Is that actually true? For example, if you measure the resonant frequency of a coil, like a Tesla coil, you can calculate the capacity of that coil. But how do we check if that capacity is actually the capacitance of that coil? There's no really good way to do that. So how can we verify if it's true that the energy comes from the power supply into that resonance system and there's no external energy flowing into it? Because I'm having doubts about that, mainly because a Tesla coil is an open circuit, and the conservation of energy law states that it only applies to a closed circuit. But a Tesla coil is an open circuit because it's open-ended, so it can interact with the ambient medium, especially when the voltages get really high, because the electrostatic field then can terminate outside of the coil. And when that voltage is changing again, when the electrostatic lines of force start moving, it will drag along energy from outside of the coil, into that resonance system. So if that is true, how can we check that? Well, I thought of an experiment that proves if it's wrong or right. It is a dual resonance circuit that is dual powered. So each resonant coil is powered, and these coils are both capacitive coupled and also are inductive coupled. This way I can create a positive feedback system whereby one power supply should feed into the other power supply, and then we can see if the resonant energy rises from the ambient energy or if it stays stable and the same. If you want to see the result of this experiment, click the link in this short video and see it for yourself.